Hello! In the past few videos, I have been telling you about the discovery of the structure of an atom. Moving on with that story and talking about the entire timeline, today I'm going to tell you about the discovery of nucleus. Well, initially in 1808, it was Delton who had given the model of the first idea of an atom, and he had said that all matter is made up of tiny particles which cannot be divided, and these particles were known as the atoms. He imagined them to be solid spheres, and these spheres would make up all matter by difference in their arrangements, and since atoms of different elements were different, they would have different properties, and he even talked about their combining to form compounds. This was in 1808. In 1898, almost in the last part of that century, it was Thompson who discovered electrons, and he gave his Thompson's plum pudding model, which he said that he discovered the presence of electrons, but he did not yet know about the protons. But he was intelligent enough to know that an atom on the whole is neutral, therefore there should be positive charge in an atom. So he said, an atom is like a ball, a sphere of positive charge, in which negative charge is embedded like plums in a pudding. So this was known as the Thompson's plum pudding model. Then in 1919, it was Goldstein who discovered the presence of the positively charged particle, which he called the proton. And it was not until 1932 that the neutron was discovered. But in the middle of these, in 1911, Rutherford with his friends, which was Hans Geiger and Ernest Marsden, they performed an experiment which is famously known as the Rutherford's alpha scattering experiment, or the Rutherford's Goldstein experiment, and they discovered the presence of a nucleus. And that is how the nuclear model of an atom came into existence. Let us see, what did Rutherford do? He took a circular screen and he took a thin gold foil. A circular screen and a thin gold foil, and he had a source of alpha particles. The source of alpha, what is an alpha particle? An alpha particle is a helium nucleus, an atom of helium from which 2 electrons have been removed to leave just the 2 protons and the 2 neutrons is what we know today. At that time we only knew that it was a heavy particle which was very, very small in size, heavy in the sense that it had 2 positive charges but a mass of 4 AMU, and it was positively charged, and it was extremely tiny, but it had force. So he took a lead plate in between with a hole so that the alpha rays could be focused at a point, and he bombarded them over this gold foil. The gold foil was like our aluminium foil that we use to wrap our food in. And this foil was very, very thin. It was so thin that these scientists claimed that it had just about 2 or 3 atoms in the sheet. So I just tried to replicate his apparatus with this hairband, that the circular screen would have been somewhat like the hairband, and he put it, and the gold foil was like this thin sheet of paper. So he had this, if you see, he had the screen, and in the screen in the middle he had put this gold foil. The gold foil. And this gold foil in a screen, and he used the alpha particles. The alpha particles were nothing but like this gun that can put light over the gold foil. The alpha rays, this is like the laser gun, shooting light at the gold foil. So do you see, when you shoot light at the gold foil, what was he expecting? If the rays would pass through the gold foil, the screen behind would get illuminated. The screen right behind it would get illuminated. So what did he expect? He expected the ray, the alpha particles which were going here, if the gold foil was very, very thin, and as according to Thompson's model of an atom, the positive charge was like a pudding, which was not very dense, and the entire positive charge was scattered all over the atom. Therefore, he expected the atom to be somewhat empty. And he said that this is what he was expecting, but what were his observations? There were three very marked observations that he made. The first was, as expected, the alpha particles, they passed through the gold foil and they went straight and hit the screen behind it. This was expected. They hit the screen right behind, and the point, since the screen was fluorescent, the point behind this, it started glowing, and he knew this was expected. And then he continued bombarding more and more alpha particles, and what did he observe? That some of the alpha particles, they were deviated from their path. They were deviated. Some through small angles and some through larger angles. And he even noticed that some of the alpha particles which were coming here, they were completely rebounded. That they came as if an alpha particle came here and it almost went back 180 degrees. Although this is not 180, would be right behind this, and if the screen would be brought here very close to this, he would see the scintillation here. So he noticed that these particles, they were not going through, some of them were deviating, and some were deviating through such large angles that they were almost coming back, as if a ball had hit a wall and it was rebounding. It was coming back. Like you hit the striker in a carom board, it hits the wall in the front and then comes back. It was as if it had hit something very hard and it came back. But Thompson's model did not indicate the presence of anything hard. It only felt as if it was like a sponge, and through which these alpha particles should have been, it was expected that they would simply pass through it. And that is what had happened. Most of the rays were going straight. But the ones those were deviating, and there were a few which were absolutely rebounding. From these three observations that he made, he concluded something. He said that the alpha particles are positively charged. And if they are positively charged, how is it possible that they are deviating from their path? They can only deviate from their path if there is positive charge which is pushing them away. Because do you observe that these rays, they were diverging, they weren't converging. If it was a negative charge, it would have moved towards it. But these were moving away, so which meant that there was positive charge somewhere which was pushing the rays, the alpha particles away. So he imagined this to be the structure of an atom. He said the negatively charged electrons may be scattered, but the positive charge in an atom is not scattered all over. The positive charge of an atom is present at one place. And it's very small. Why did he feel that it was very small? What was the first observation? That most of the particles just passed through the gold foil. From this he concluded that most of the atom is made up of empty space. That the particles were just passing through. It meant most of the atom was made up of empty space. The second observation was that some of the particles were deviating. From this he concluded that the positive charge is not scattered. It is at one point, and this point it's very small. Why is it very small? Because most of the atom should be empty. If most of the atom should be empty, this positively charged portion of the atom should be extremely small, and all the positive charge should be concentrated in that little area, and he called this the center or the nucleus. So he said there should be a nucleus, and this nucleus should be positively charged. And that's the reason why these alpha particles were being deviated from this nucleus. The third was, all right, there was deviation. Why was there a complete rebound? As if the alpha particle had hit a wall and it came back. Why was it coming back? He said that positive charge is extremely dense and it's extremely dense like a solid sphere, and then when the alpha particle comes and hits this solid part, those particles, 1 out of 200,000, they get rebounded. 1 out of 200,000 of the alpha particles were completely rebounded. So he said that these particles are actually coming and hitting the nucleus, and that is why they are moving back. So he said if alpha particles are moving straight, it's because most of the atom is empty. The closer an alpha particle comes to the nucleus, the further it moves away, that is, it deviates. And the one which comes and hits the nucleus gets a complete rebound and returns. So from this, he gave his model of atom, which was known as the nuclear model. So the nuclear model did not actually look like this, it looked somewhat like this. He said the positive charge of an atom is concentrated in the center, and that center is called the nucleus, while the electrons, they revolve around the atom, and he imagined it to be somewhat like the planets revolving the sun. He said just like the planets revolve the sun, it is these particles which, the electrons, which revolve around the positively charged nucleus. But remember, at this time, the existence of neutrons was not known. It was only known that positive charge, which is the entire mass of an atom, is concentrated here in the center, and the electrons revolve around it in orbits. So today, we can imagine the atom to be somewhat like the electrons to be not moving in certain orbits, rather they are buzzing like bees around the atom. And this buzzing is what the quantum mechanical model would express. They do not travel in certain orbits, but rather they are like bees buzzing around it. So it was now in 1919 that the proton was discovered. What had Rutherford told? He only talked about positive charge being concentrated. He did not know about the particles called protons. And it was Chadwick in 1932 who talked about the neutron. And then the next model the idea of it was given, where it was said that the protons and neutrons together make the solid nucleus. So this was Rutherford's nuclear model of atom. Thank you for watching.